Hello everyone. Hello Pradeep. Good evening everyone. I hope you are able to hear my voice, and if you can, please give me a notification in the chat so that you can that you are hear my voice or not. Then we will start, and today we are going to discuss another chapter, magnetism and matter. And as I said, in case of important chapters, there are no such thing as important chapters. There are few chapters which are small, so less number of questions possible, and there are some big chapters where a lot of questions are possible. For example, magnetism and matter, we have only 30 questions from this chapter. Previously we have solved 35 questions from all the chapters. Hi Ali, if you can hear me, please say that you can hear me, and I will start it as soon as I can, right? So let's start with the class. First we will start with this question. Consider the following statements. Statement 1, magnetic field lines do not intersect each other. Okay. Statement 2, if the magnetic field lines intersect, the magnetic field would not be unique at the point of intersection with reference to the above statements. Okay, both statements are true, and statement 2 is the correct explanation of the statement 1. Both are true, and statement 2 is not the correct explanation of the statement 1. If statement 1 is true, statement 2 is false, as usual. So we have to first identify if both statements are correct. Hi gaming, welcome to my lecture. Pradeep, yes, thank you. So first you have to identify both statements are correct or not. So from the properties of magnetic field lines, we know that magnetic field lines do not intersect each other, right? We already know that. So this is a correct statement. This is the correct statement. Now let's see the statement 2. If magnetic field lines intersect, the magnetic field would not be unique at the point of intersection. That means if two field lines intersect, at the point of intersection we will have two different direction of magnetic field, which is not possible in any space in magnetic field. There will be only one direction of the magnetic field, but in this case we have two different directions, which is not possible. So definitely statement 2 is also correct, and if it is a correct explanation or not, that you have to identify and answer it. Okay, so let's say, hi Varija, yes, welcome back. Sir, please provide PDF of these questions on all Chakravyuh series. Yes, gaming, we will provide the PDF series, don't worry, it is already safe. We will provide the all the solutions, all the PDFs for this. So just few days, as soon as the series is over, we will give you all the PDFs at one go, or I will ask my team to share the link at least for the first 15 classes. Today is the 15th class, so I will arrange them, and I will try to provide them as soon as possible. Don't worry, it is already in the agenda, and as you know, Aishwarya ma'am handles all these things, that whether the files are being maintained or not. So day before yesterday she was asking that, sir, your two of your classes are not there in our drive, so you have to update that. We want to share it with the students. So everything is in place. We will definitely share it as soon as possible, right? Yes, we will give you, but provide as soon as possible. Yes, Monday I will try to give you the first 15 PDF link in a single link. You don't need to click on 15 different links. You will only get one link. From there you can see all the 15 classes, physics, chemistry, maths, biology. So don't worry about it. Okay, and if you have any other doubts, please mention it at the end of the lecture. Right now let's see, both statements are correct, and statement 2 is the correct explanation of the statement 1. Yes, obviously students already answered it. Pradeep and Varija already answered. Yes. Now let's move into the next question. Question number 2. When the angle between the magnetic moment of a small compass needle and the uniform magnetic field in which it is placed is theta equals to 90, theta is equal to 180 degrees. So we have already a magnetic field is there, and a magnetic moment of a small needle is basically they are in the 180 degree angle. The torque on the needle is maximum. The needle is in a stable equilibrium. The potential energy of the needle is 0. The needle is in unstable equilibrium. So you have to identify the correct answer and answer this question. Okay, so the needle is kept like this. So what will happen to this needle? The torque on the needle is maximum. The needle is in stable equilibrium. The potential energy of the needle is 0. The needle is in unstable equilibrium. 2D. Varija is saying 2A. So what is the torque? Let's see. Torque is magnetic field into magnetic moment sin theta, right? So torque is Bm sin theta. Now sin 180 degree is -1, so torque will be negative, but obviously it will be having a maximum value. Okay, so torque will be maximum possible value, right? Or torque. Am I making a mistake here? Torque is m cross b, right? M cross b, so it is Bm sin theta. Sin 0 is 0, sin 90 is 1, sin 180 degree is 0. So torque will be 0. Torque will be 0. Torque will be 0 in this case. Okay, even though it is like this, the torque because it is in the opposite direction, it will be 0. Torque will be 0. Next is the needle is in stable equilibrium. Definitely it is not in stable equilibrium. Stable equilibrium will be only when the magnetic moment and the magnetic field they align with it themselves. This is a stable equilibrium, right? Now needle is in potential energy of the needle is 0. Potential energy of the needle is not 0 in this case. Again, if the needle is in stable equilibrium, then only potential energy will be 0. So potential energy is also not 0, but needle is in unstable equilibrium. Why in unstable equilibrium? If you try to move it, as soon as you move the needle, it will try to align itself in the direction of the magnetic field. So stable needle is in the stable equilibrium, unstable equilibrium, sorry. So this is the correct answer. Option 2D is the correct answer. Now next move on to the question number 3. A magnetized needle placed in a uniform magnetic field in general experiences. So magnetized needle in general placed in a magnetic field experiences. So the angle is not specified how it is kept, okay, uniform, but it is mentioned that uniform magnetic field. That is very, very important. If it is a non-uniform, the answer will be different. If it is an uniform, answer will be different. Okay, both force and torque, a force but no torque, a torque but no force, neither a force nor a torque. Okay, so answer Pradeep is saying 3A, Varija is saying 3C. Shaudamini, Isha, yes, your answer was correct. Lakshmi, your answer was also correct. Pradeep already answered correct. Vignesh, whenever you are answering, you have to answer with the question number. So because the magnetic field is uniform, it will only experience a torque, it will not experience as a force. Okay, if the magnetic field is not uniform, then only it will experience both force as well as torque. So be careful. So only a torque but no force. Okay, so when the magnetic needle is placed in an uniform magnetic field, it will only experience as a torque but not any magnetic force. Yes, Varija was right. Some people already deleted their answer. Yes, yes. So please don't delete your options, don't delete your answers. Let me see. Okay, and making mistakes is correct. Sometimes making mistakes help you to learn. And also remember that whenever you posting your answers, you have to be careful and mention the question number, please, because we are moving too fast. If you answer slightly 1 second after that, I can still see your answer, but you have to mention the question number. Easy. This is the easiest question. When a freely suspended magnet comes to rest in the direction, I will not take any answer from you, it is north south direction. Okay, freely suspended magnet comes to rest in the direction of north south. Easy question. Without any answer, I will move to the question number 5. No option. Question number 4 I will not check. If you answered wrong, I will not check. Right? Yes, I know. According to Gauss' law of magnetism, magnetic flux through a closed surface may be non-zero. Magnetic monopoles do not exist. there can be sources or sinks of magnetic field, the magnetic flux through any surface is 0. Okay. So, these are the few questions. Very interesting question. There are two options which might feel correct, but only one of them is correct. So, be careful. Options are interesting. Question is simple. Options are interesting. Okay. So, be careful. Just this is a tricky question. Very simple, easy question, but people will confuse. As I suspected. Vignesh answered 5D, Varija answered 5B, Pradeep answered 5D, Lakshmi answered 5D. Now, why 5D is not correct? Why option B is correct? So, they have mentioned that magnetic flux through any surface is 0. So, not any surface is 0. You have to understand magnetic flux through a closed surface. Closed surface is 0. That is the difference. If it is a closed surface, then it would have been a correct option. Okay, but they have not mentioned the closed thing, so this is not a correct option. Okay, magnetic monopoles do not exist. That is why magnetic flux through any closed surface is 0. So, whatever is coming in, the same is going out. Okay. So, any closed surface is 0. If it is an open surface like this, it can have magnetic flux through it. Okay, it can have magnetic flux through it. Right, that is the basic principle of electromagnetic induction. Magnetic flux is changing through a loop, through a coil, that they are not closed surfaces, right. So, that is why if the surface is open, magnetic flux will not be 0. Electromagnetic induction happens because of that, right. But if the surface is closed, whatever is incoming, the same amount is outgoing. That is why total magnetic flux through a closed surface is 0. That is why I said this is a very tricky question, and 90% students, those who do not read the question properly, they will see this option D and they will answer it. Only 10% students, they will realize the inherent meaning of the Gauss's law. Magnetic monopoles do not exist. This is the correct statement. So, this is where you make mistakes. I hope now whatever doubt that you might have is cleared, right. That is why I say read the question before answering. The dimensional formula for magnetic intensity. So, what is magnetic intensity? Magnetic intensity is H. So, what is the dimensional formula? No, not H, I think. Anyway, magnetic intensity I. What is the formula for magnetic intensity I? Sir, which is tomorrow's class? Pradeep, tomorrow there is no class. Tomorrow is Sunday. So, Sunday we also want to take some rest. Teachers want to get refreshed and come alive. So, tomorrow there will be no class. Okay, Monday I will take again. Monday is my turn. Okay, this Saturday was also no class was scheduled originally, but I am taking because I want to complete the syllabus as quickly as possible. So, I am taking this class. Next Sunday there will be a recorded class. Okay, next Sunday there will be a recorded class. Either physics or chemistry or maths or bio, I am not sure, but next Sunday and I think next Saturday as well there will be recorded class. Okay, it will not be a live class. Monday to Friday we will have a live class session as usual, and Saturday and Sunday, next Saturday and Sunday will be recorded classes. You will get the class, but I will not be able to interact with you because obviously, but we are trying to, but the chapters that we will discuss during the recorded session will not be super important theoretically. For example, electromagnetic waves, that is not super important chapter in theoretical terms, so that will be a recorded class. Atoms and nuclei, they are not super important classes, they will be recorded classes. Okay, but all the other important chapters, for example ray optics, wave optics, dual nature, they will all be live classes, so don't worry about it. Okay, we will try to take as many live classes as possible, but due to the times constraint also we have our our personal life as well. So, since morning we are recording a lot of classes and then I am taking this live session. So, all the classes as much as possible we are trying to keep it live, but some classes will be, some less important classes will be recorded as well. Now, let us see the dimensional formula for magnetic intensity is. So, magnetic intensity is length per ampere inverse. Okay, correct answer is option C. Let us see. Sorry. It will be length inverse ampere per length. So this is the correct answer. Option 6B is the correct answer. Yes, right. Now let's move on to the next question. If the magnetic susceptibility, and don't do internet research while I am answering. The magnetic susceptibility of a material is 100. Its relative permeability. What is mu r? Okay, mu r. Relative permeability, what is mu r, and chi is given as 100. What is the relationship between chi and mu r? Okay, so chi is equal to mu r plus 1. So mu r will be chi minus 1. So it will be 100 minus 1, that is 99. If you don't remember the formula, this is the answer. Yes. No, it is 100. A chi is equal to mu r plus 1. Okay. Mu is equal to 1 plus chi. Okay, I will check it. I will check it. Why is I saying mu is equal to chi plus 1? Maybe okay. Yes. Mu is equal to chi plus 1. Yes. Mu is equal to chi plus 1. Yes. 7. C is the correct answer. Now, next question. For which of the following substances the magnetic susceptibility is low and positive? Very interesting. So, magnetic susceptibility is low and positive for which of the following substances? Bismuth, copper, iron, sodium. Bismuth, copper, iron, sodium. Now answer this. Shaukat Ali, hi. This is a very interesting question. What is the type of the material? Basically they are trying to say which of them is basically a paramagnetic substance. Okay, which of them is a paramagnetic substance? I think there is a mistake in the question. Why so? Because there are 3 substances which have low and positive susceptibility. Only one is negative. So let's change this question. Change this question to negative. Okay, 3 of them have positive and low and positive susceptibility. Only one of them has negative susceptibility. Let's understand that. Please check. I have changed the question. Pradeep, please check the question. Yes, paramagnetic. Yes, which of them is paramagnetic? Yes. So negative is only bismuth. Now copper is a metal, even though it is not a ferromagnetic material, it is a metal. All the metals are by nature they are paramagnetic. Okay, they have some unpaired electrons, so that is why they are paramagnetic inherently. So you have to cool it down to certain temperature to make it a magnet, but otherwise they are all by nature are paramagnetic. Okay, sodium, iron, copper, they are all paramagnetic. But bismuth is not a metal. Okay, it's a metalloid, so that's why it is a negative. It has a negative susceptibility. So this is a diamagnetic material. Okay, so bismuth is a diamagnetic material. All other materials, copper, iron, sodium, they are metals. So they are paramagnetic materials by nature. We have to be careful about this. Now next question. Something big is coming. So I said at the beginning that something big is coming, and then many students trolled me on Monday's class that sir, you said something big is coming. When it is coming? It was supposed to happen last Sunday, but we have changed the time. It is 3rd February 11 AM in the morning. We will be coming live. Okay, so be there 3rd February 11 AM. I know many of you are having practical exams, but most of you are having no colleges are right now going on, right? So 3rd February 11 AM will be coming live. It will be a short live, not huge long live. So just stay there, be with us. Okay, some big announcement is happening, and it is regarding the KSET 2025 course. Okay, KSET 2025 aspirants, and it is something what everyone is expecting, so everyone is asking. So something related to that, I will not divulge too much about it. So you have to wait for one more day. Sunday is there in between. Sunday you have to wait, and Monday morning we will be discussing what we are going to do, and it is something happy. You will be happy after hearing that. Okay, now let's move on to the question number 9. In the following table, column 1 lists magnetic substances and column 2 lists some magnetic properties of the substances. Okay, diamagnetic substance, paramagnetic substance, ferromagnetic substance. Okay, now which of the column 2 and column 1 is matching? So I can tell you that obviously I can see one of the column 2. Column 1 is easy. Column 2 is mu is less than mu naught, domain formation chi m is greater than 1. Okay, so domain formation happens only in ferromagnetic substance. This much I know. So I will start by matching this one. Okay, now I will see whatever is other options are given. Okay, now chi m is greater than 1 for paramagnetic substances. Okay, and diamagnetic substances have permeability less than mu naught. Okay, so this is the obviously the correct match. Let's see the answer. A is matching with P, B is matching with R, okay, and C is matching with Q. So correct answer is option B. Okay. Somnath Shetty, kindly do marathon for boards. We have already did a very long series called PU2 Brahmastra series, where all the important questions are discussed. Next, for boards, we will be doing your model question paper solution from Monday onwards, I think, or Tuesday onwards. That series will also start. All the model question paper that is given by your boards, 3 model paper per subject, physics, chemistry, maths, biology, all 4 subjects will be covered. Okay, so all 3 model question papers will be covered. So I hope that is sufficient. This is also for your board exam only. These MCQs are for your board exam only, right? Iron is ferromagnetic, you said. No, iron is not ferromagnetic. Iron is paramagnetic. All the metals by nature is paramagnetic. Iron is ferromagnetic. Sorry, my mistake. Iron is ferromagnetic. All the metals by default are paramagnetic. If they are below Curie temperature, they are behaving like ferromagnetism. Okay, so for example, copper, nickel, iron, nickel, cobalt, they behave. Their Curie temperature is above room temperature. That's why they behave like ferromagnetic. And gadolinium. Gadolinium is a very interesting material whose Curie temperature is around 27 degrees Celsius. So you can see how it changes from para to ferro if you cool it down sufficiently. So that is one thing. And all the metals actually are paramagnetic by nature. You have to cool it down below room temperature, say maybe some minus degree Celsius, to make them magnet. Okay, but all the metals by default are paramagnetic in nature. Okay, iron was ferromagnetic in that example. My mistake. Yes, yes, nickel. I said cobalt, nickel, and iron, right? No, sir. Copper is diamagnetic. You check your answer. Copper is not diamagnetic. Copper is paramagnetic. Okay, copper is paramagnetic. All the materials, inherent property of all the materials is diamagnetic, but copper is paramagnetic. Okay, you have to cool it down below certain temperature. Even some some alloys are being used in copper to make it a magnet. Okay, you can check that out. So question number 9 is 9B. Now say question number 10. Atoms in which kind of magnetic materials have permanent magnetic dipole moment? Okay, atoms in which of the kind of magnetic materials have permanent magnetic dipole moment? Only diamagnetic substances, only paramagnetic substances, only ferromagnetic substances, both para and ferromagnetic substances. So permanent magnetic dipole moment. Very important. Permanent magnetic dipole moment, which of the following substances can have? Okay, I will check your answer. Aman, I will check the answer. Copper is not paramagnetic, copper is diamagnetic. I will check the book. Okay, I will check and I will tell you. Shaukat Ali is saying 10C, Pradeep is saying 10B. Permanent magnetic dipole moment is possible only in case of ferromagnetic. It is not possible for paramagnetic. Paramagnetic, they do not have any permanent dipole moment. Their domains are gone. Their domains are completely destroyed. That is why they are paramagnet. But below certain temperature, they can have a permanent dipole moment, permanent magnetic dipole moment. That is only ferromagnetic. So also, if they have permanent dipole moment, that means they are actually magnet. Okay, permanent magnetic dipole moment means they are already a magnet, and magnet is only possible from ferromagnetic substances. Paramagnets cannot become a magnet, right? So this is the correct answer. Okay. Now let's move on to the question number 11. Which magnetic property is a strong effect? Paramagnetism, diamagnetism, ferromagnetism, both paramagnetism and ferromagnetism. I am not clear about which is a strong effect. I don't understand the question. It was taken from your sample paper model question bank, I guess. Okay, but I don't understand what is the meaning of strong effect. If you have any idea, please answer. Hysteresis is possible for. Hysteresis is possible only for ferromagnetic substances. Hysteresis is not possible for dia or paramagnetic substances. Okay, hysteresis loop is only, you can check hysteresis loop when it becomes a paramagnet. Okay, ferromagnet. Sorry, they are answering. Question number 10, paramagnetic mentioned in the syllabus. Permanent dipole moment, it is, if it is mentioned in the NCERT, then it is wrong. It is wrong. If it is mentioned in the permanent dipole moment is possible only in ferromagnetic substances. Okay, permanent dipole moment, very careful. Permanent dipole, magnetic dipole moment means they are already a magnet. Okay, you may be confusing with electric dipole moment. Okay, electric dipole is different, here it is magnetic dipole moment. Okay, electric dipole moment is different, magnetic dipole moment is different. Okay, be careful. Permanent dipole moment means it is only a ferromagnetic substance. If this is written in NCERT, then unfortunately it is wrong. Okay, you can mention the page number if you can find, Pradeep. I will check it definitely, and if possible I will ask the NCERT as well. Now, which of the magnetic property is a strong effect? I don't understand this question. What is the meaning of strong effect? Strong effect, in my opinion, ferromagnetic can be a strong effect. Okay, it can become a strong magnet. Okay, but what is the meaning of strong effect? I don't understand. Many are saying a strong magnetic effect. Okay, strong magnetic effect. Yes, strong magnetic effect. Yes, that then it makes sense. Strong magnetic effect. Which of the magnetic property is a strong magnetic effect? Ferromagnetism is the strong magnetic effect. It has the capability of concentrating all the magnetic field inside it. So that is why it can show strong magnetic effect. Now, question number 12. If a magnetic substance is kept in a magnetic field, then which of the following substance moves out of the magnetic field? Very interesting. A diamagnetic, paramagnetic, ferromagnetic, both diamagnetic and paramagnetic. Now, this is an easy question. Yes, sir. Please check page number 148, line number 5. It is mentioned as permanent dipole moment is by permanent paramagnetic. Okay, I will check, Pradeep. Don't worry. Thank you. I'm just taking a screenshot of this. It is saved. I will check, and I will definitely reply in the main comment section of this video. I will reply. Okay. If a magnetic substance is kept in a magnetic field, which of the following substance moved out of the magnetic field? Straightforward, easy question. It is diamagnetic substance. Diamagnetic substance are repelled by no, not 12D. Anish, no, not 12D. Yes, Varija, Shaukat Ali, Pradeep, you are correct. It is not 12D, it is 12A. Diamagnetic substances are getting repelled by the magnetic field. Paramagnetic are getting attracted very weakly, and ferromagnetic are getting attracted very strongly. Okay, so only diamagnetic substance will be repelled out. Okay, so they will move out of the magnetic field. Next question, the ratio between magnetization and magnetic intensity. So the ratio between magnetization and magnetic intensity is called M by I. It's called permeability, it's called relative permeability, it's a dimensionless quantity, it is a reciprocal of susceptibility. Interesting question. What is the ratio is called? 13C. Any other answer? Why 13C? Why dimensionless quantity? What is the dimensionless quantity name called? Teju came with the answer 13D, the reciprocal of susceptibility. So, if I remember correctly, I is equal to chi into m. Okay. So, m by I will be 1 by chi equals to m by I, if I remember it correctly. So, this will be the correct answer. And magnetic susceptibility is also dimensionless. So, this is something interesting. So, it is a dimensionless quantity as well. Okay, reciprocal of susceptibility, and it is a dimensionless quantity. Maybe there are some other quantity involved in this, but this is the basic formula. Okay, it is a dimensionless quantity and it is a reciprocal of susceptibility as well. So, both should be correct. So, some questions are like that. A compass needle of magnetic moment m is placed in a uniform magnetic field B such that the angle between them is theta. So, magnetic moment m and magnetic field, the angle between them is theta. Okay. The ratio of magnitude of the torque on the needle to the potential energy of the needle is proportional to. So, potential energy and torque divided by potential energy, magnitude of torque and divided by potential energy, it is proportional to what quantity? 14C, yes. So, torque is basically sin theta and potential energy depends on cos theta. Okay. So, if you find the ratio between them, it will be easily tan theta. Okay. They have not given cot theta, that could have been another interesting answer. So, but it is easy. We know that torque is a vector quantity, all the vector quantity, whenever they are involved, there should be a sin theta involved, and potential energy is, on the other hand, is a scalar quantity. Whenever there is a scalar quantity involved, a dot product, that is cos theta is involved. So, this is a way to remember even if you do not know the answer. Now, next question. This is a very interesting question. Okay. The following figure shows a small magnetized needle. Let me move it here so that you can read the question first, then I will move to other side. Okay. The following figure shows a small magnetized needle P placed. So, this is the magnetic needle P. This is already placed here, this one. Okay, this fellow. Okay. P placed at point O. The arrow shows the direction of its magnetic moment. Other arrows show different positions and orientations of magnetic moment of another identical magnetized needle Q. Okay. Which of the following statements is false for the above configuration? So, here we have a magnetic needle, it is already placed like this, and we are trying to place different needles like this. This is kind of a KSET level question, but it was again taken from your model question bank. So, this is interesting question. Now you have to identify which of the following statement is false. In configuration PQ1 and PQ2 and PQ2, okay, the system is not in equilibrium. So PQ1 and PQ2 system is not in equilibrium. Okay. The system will be stable equilibrium for configurations PQ3 and PQ6. System will be stable equilibrium for PQ3 and PQ6. The system will be unstable equilibrium for the configuration PQ4 and PQ5. Unstable equilibrium for PQ4 and PQ5. Okay, and PQ6 corresponds to the maximum potential energy state among the given configurations. PQ6 corresponds to the maximum potential energy state among the given configuration. So you have to remember that 3 of them are correct actually. 3 of them are correct, only 1 of them is false. So you have to identify the false statement. Okay. (15b) the system will be stable equilibrium for configuration PQ3 and PQ6. So you are saying that this is not stable equilibrium for PQ3 and PQ6. This is correct statement only. So let's see one by one. Let's understand one by one. So first we will identify the first option. In configuration PQ1 and PQ2, the system is not in equilibrium. So as you can see, if you release PQ, these two magnetic needles, what they will do, they will try to orient in the opposite direction so that it cancels this. So this is the magnetic needle, right? That means this is the north pole, this is the south pole. Okay, magnetic field goes from south to north. So this is south pole, this is north pole. Now for this is north pole, this is south pole. So what will happen, as soon as you release this south pole and this north pole will start attracting, and this will try to orient such that it will try to orient itself such that this north pole and south pole stays closer together. Similarly for this also, north and south, north and south. So they will also orient such that north and south are attracting. So this is obviously not, system is not in the equilibrium case. The system will be stable equilibrium for PQ3 and PQ6. So PQ3, as you can see, PQ3, so this is north south, this is north south. So this, they are forming a pair. Forming a pair means this is the stable equilibrium. And for PQ6, what is the case? Again north south, north south. So they are again forming the pair. So this is also a stable equilibrium. Okay. Now let's see the question number C. The system will be unstable equilibrium for PQ4 and PQ5. So PQ4 and PQ5, so they are same, they are oriented in the same direction, in this case opposite direction. Okay, but what will happen is that they will be in the stable equilibrium, unstable equilibrium. If you move them, then only they will try to move, otherwise the torque acting on them is 0. Torque acting on them is 180 degree, right? So angle is 180 degree means torque acting on them is 0. So they will initially not be compelled to move from their initial position, right? But if you slightly move them, as soon as the angle is no longer 180 degree, they will experience as a torque and they will try to orient themselves in the opposite direction, right? So this is why it is called unstable equilibrium. Okay, whereas PQ6 corresponds to the maximum potential energy state among the given configuration. So maximum potential energy state amongst the given configuration is only when this is the maximum potential energy, this is also maximum potential energy. Both are stable equilibrium. Both are stable equilibrium. That means both will have the maximum potential energy. right? So in this case also the potential energy is maximum, that is why they are in stable equilibrium. Stable equilibrium means potential energy is maximum. So PQ6 is not the only one, this will also have the maximum potential energy, that is why option D is incorrect. So that's why I said this is a little higher level question, so you have to be careful. Yes, very difficult question, Pradeep. I agree with your answer. I agree with your answer, but this is from your model question bank. This is a model question bank. If this question comes in your PU final, they will say we have already released the model question bank, why you have not solved it. That is why I say solve the question. If you try to remember that whenever there are equilibrium, okay, if you have missed the chapter equilibrium in your first PU, rotational equilibrium, rotational motion chapter, there we have discussed about equilibrium. Okay, so equilibrium means if equilibrium basically represents when all the forces or all the torque acting on the system is 0. Okay, if the forces are 0, it is called linear equilibrium. If the torque is 0, it is called rotational equilibrium. Normally equilibrium means force, torque, everything is 0, then it is called equilibrium. Now there are two types of equilibrium: stable equilibrium, unstable equilibrium, and one is neutral equilibrium. Okay, so stable equilibrium means even if you move it, it will come back to its original position. So just to give you a idea, so there are three types of equilibrium. Okay, so if you keep an object here, what will happen if you move it small amount on the left side or right side? It's like a limit. You have done the limit, right? Limit x tends to 0 plus, limit x tends to 0 minus. So it is like the limit. If you move it slightly right or left, it will stay slightly right or left, it will not change, it will stay at its original position, it is new position. So this is a neutral equilibrium, this is called neutral equilibrium. If you keep a object here in this region, okay, if you move it slightly right or left, what will happen? It will fall back and it will try to regain where it was. Okay, it will stay in its original position. So if you even if you push it slightly right or slightly left, it will come back to its original position. Then this is called a stable equilibrium. This is an example of stable equilibrium. But if you keep it on top of this position, initially it is at rest. Initially it is at rest. But if you slightly move it right or left, then it will no longer be in equilibrium. This is called unstable equilibrium. These are the common thing. Okay. What are the methods to decrease intensity of magnetic field? So decrease the intensity of magnetic field, either there are different what you are talking about. If you are talking about solenoid, to try to decrease, you have to reduce the current. Okay, you have to reduce the number of turns, or you can reduce the whatever core you are using. So less ferromagnetic material you are using, then it will be reduced. Okay, this is the only way to reduce the magnetic intensity. Otherwise, what you can do, if it is already a magnetic field, you can keep a ferromagnetic material. The magnetic field intensity will increase inside the ferromagnetic material, but it will decrease elsewhere. All the outside region it will decrease. That is another way to decrease magnetic field intensity. Okay. Mohammad Zaid, you missed something. I have one big announcement we have done. Wait for Monday, we will reveal a new plan of action for all the KSET students. Okay, Monday 11 AM there will be a very big update for all the KSET students. Okay, so till then please wait. Now question number 16, needles N1, N2 and N3 are made of ferromagnetic, a paramagnetic and a diamagnetic substance respectively. The magnet when brought close to them will attract N1 strongly but repel N2 and N3 weakly, attract N1 and N2 strongly but repel N3, attract N1 strongly, N2 weakly and repel N3 weakly. Attract all three of them. So obviously the question you don't need to see the answer, you can easily answer it. Okay, the ferromagnetic substance will be attracted strongly, paramagnetic substances will be attracted weakly, and diamagnetic substance will be repelled weakly, right? So answer is 16C. Yes, you don't need to check anything because they have given the option such a way that you can easily answer. Okay, this is a ferromagnetic substance, this is a paramagnetic substance, this is a diamagnetic substance. Okay. Now let's move on to the next question. When a bar magnet is suspended freely, it points out. Same question, only the option orientation is different. This will be north-south direction. Whenever you suspending a bar magnet, it will face north-south direction. I will not waste time on such questions. The ferromagnetic material among the following is. So which one is a ferromagnetic material among the following? Another question, copper, nickel, lead, calcium. Easy question. 16C, yes, 16C was correct answer. What is dynamo effect? Dynamo effect, it will take some time to explain. It is basically when you keep a current carrying coil inside a magnetic field, it starts to rotate. That is a example of dynamo effect. Okay, so basically all the electric motors work in this principle. That is called, it is called dynamo principle. Okay, this is the brief answer. The entire explanation will take some time. Okay, if you keep a coil, rectangular coil inside a magnetic field, it experiences a torque. Because of that torque, it rotates. Okay, that is the dynamo effect. 18B, yes, nickel. Nickel is a ferromagnetic material. Now next question, another match the following type question. The physical quantities related to magnetism are listed in the column I and the dimensions are listed in column 2. Identify the correct match. Magnetic field, magnetic permeability, magnetic moment. Okay, magnetic moment is easy. Magnetic moment, magnetic permeability is slightly tricky, and magnetic field is slightly easy. So magnetic moment, can I give you a hint? Okay, magnetic moment is basically this one. Okay, now I will not tell you anything else. I asked about Earth's magnetic dynamo effect. I am not sure about this Earth's magnetic dynamo effect. I need to study, then only I can answer. 19C, yes, 19. Yes, there when typing this question, there is one interesting thing is ACBD was happened. So yes, option C is correct. One is matching with C. Okay, this is the magnetic field. Magnetic permeability is this. Okay, and 3B, that's why I said only one is correct answer. 3B is the only one correct matching, 3B. So you don't need to check the others. You can say Earth's magnetic dynamo effect. I think you are talking about due to the rotation of Earth, there is a magnetic effect working on us. Okay, that might be some case. I have to do some study on that, then I can answer you. Okay, I am not super sure about the answer for that question. Statement number 1, the net magnetic flux through any closed surface is 0. The number of magnetic field lines leaving a surface is balanced by the number of lines entering it. Okay, so this is the two statements, and the options are as usual. In A, both are correct. Okay, and 2 is the correct explanation. Okay, B, both are correct but not correct explanation. C, both are wrong. 1 is correct, wrong. B is correct, and D, 1 is correct, 2 is wrong. Okay, yes, yes, yes. So both statements are correct and it is the correct explanation. I already explained briefly that a number of field lines entering a surface is the same as the number of field lines exiting it. That's why the magnetic flux through a closed surface is always 0. So you have to be careful about this. This is like the closed, if the closed is mentioned or not. Okay, if this is closed, then definitely it is 0. So student got confused in one of the questions where Shaukat Ali was not there, when the question was magnetic flux through any surface is 0. Magnetic flux through any surface is not 0, only closed surface is 0. The susceptibility of a ferromagnetic substance, very easy question. Susceptibility of a ferromagnetic substance, 21C. Yes. Sir, how many questions left? Only 9 more questions left. After this, only 9 more. 30, up to 30 we have. Okay, I will try to close it. I don't want to drag it too much. I will try to close it in next 15 minutes. Okay. The susceptibility of ferromagnetic substance is very greater than 1. Yes, 21C is the correct answer. Great. Great Shaudamini, great Pradeep, great Shaukat Ali. Now, which of the following properties is false? Another false. Okay, for bar magnet. So, true is easy to understand, but false is sometimes it's slightly tricky to understand. It does not produce magnetic field. Okay, so bar magnet saying they are not producing magnetic field. Obviously, this is the correct answer. Okay, so this is the correct answer. First option is itself is correct answer. Let's see the other options. Its poles cannot be separated. Yes, they can be. They cannot be separated. Okay, a correct statement. It points north-south direction when suspended. Yes, that is also correct statement. It like poles repel and unlike poles attract. That is also correct statement. Yes, I already answered 22A easy question. Right, does not produce any magnetic field. Very trivial question, but that is also type of question. A susceptibility of a certain magnetic material is 400. What is the class of this magnetic material? Diamagnetic, paramagnetic, ferromagnetic, non-magnetic. Okay. This is slightly interesting. Okay. Let's see who can answer this question. I'll wait 1 minute. Susceptibility is chi, it is greater than, it is 400. What is the type of the material? 23rd C, 23rd C. So now there is a confusion for this question, even though in your book it says that a susceptibility of magnetic material is slightly greater than 1 for paramagnetic and less than 1 for diamagnetic, and for ferromagnetic is more greater, but there is a limit for ferromagnetic. In your NCERT textbook the limit is given 1000. Okay, unfortunately no such limit was given for paramagnetic. Okay, this question is from, I think, from one of your model question paper or from old cassette question paper. Okay, I have not made this question myself. So this is one dilemma I have faced while answering this question. In my opinion, this will be a ferromagnetic substance, because paramagnetic cannot have more than 10. Okay, the limit for paramagnetic is 10. It cannot have a 400 value. Okay, some student quote that because the limit given for ferromagnetic is more than 1000, so this must be a paramagnetic substance, but it is not actually a paramagnetic substance either, because the limit for paramagnetic is under 10. Okay, I don't think there will be a material which can have a 400 value. If it is having 400 value, then it is a ferromagnetic substance. Definitely all the domains are not aligned. That is the only possible case. Okay, or it has a mixture of paramagnetic and ferromagnetic together. That's why the it is not actually reaching in the high of ferromagnetic. Paramagnetic is pulling it down. It can be an alloy. Okay, otherwise there is no other explanation. Ferromagnetic, obviously if it is greater than 1000, it is definitely a ferromagnetic. If it is close to 1 but greater than 1, then it is a paramagnetic. If it is less than 1, it is a diamagnetic. No other thing is there, but 400 cannot be a paramagnetic, that much is sure. Okay, so your answer will be ferromagnetic. If you see this question, you have to answer ferromagnetic. Next, the magnetic field lines inside a bar magnet are from north pole to south pole, are from south pole to north pole, do not exist, exist only when an external field is present. Easy question. Yes, all of you are correct. Shaukat Ali, Pradeep, Varija, Shaudamini, everyone is correct. Now let's see this question. Hello Kannadiga, you missed a lot of lectures. You also missed today's class. After first class I thought okay you will be a regular student, but unfortunately you missed a lot of classes, okay, a lot of my classes. So R from south to north, whoever is saying 23rd, oh no, 23rd C is correct, 24B is correct, 24A is no Pradeep, no. So you have to remember that bar magnet, if you are getting confused, you have to remember north and south. Outside the magnet it travels from north to south, okay, and inside the magnet it travels from south to north, okay. This is always outside the magnet it travels from north to south, and inside the magnet it travels from south to north, or from south pole to north pole, okay. Inside the magnet it is south pole to north pole. Next question, where when a bar magnet of dipole moment M is placed in an uniform magnetic field B, the torque acting on is given by. Hi Lakshmi, yes Lakshmi, correct answer. So now question, when the bar magnet dipole moment M is placed in a uniform magnetic field B, the torque, I have already told this answer once or twice. 25A, yes 25A is the correct answer, M cross B, okay. So 25A easy question, I have mentioned at least twice during today's lecture. Let's see, universal property among all substances. This is a question I think from your board exam last year or last to last year, okay. This is also very interesting question. Hi Lakshmi, yes correct answer, 25A is the correct answer. Saudamini, yes. Pradeep, yes. Varija is saying 26A. Let's see, anyone else with any different answer? I will wait. This is an interesting question, that's why I am giving some time. Yes, let's see. Pradeep is saying 26C. Anyone else? Diamagnetism is a universal property in all materials, but it is weak and hard to detect. Substances is para or ferromagnetic. Okay. This is the exact line written in your NCERT book. Yes. So no other Harija killed my curiosity. I wanted to check, only Pradeep answered wrongly, then he deleted his answer. Yes, diamagnetism is the universal property. Diamagnetism is present in all the substances, but if the substance is paramagnetic, then paramagnetic dominate the diamagnetism. If it is ferromagnetic, ferromagnetic dominates the diamagnetism by manifold, okay. If it is neither diamagnetic nor paramagnetic, then diamagnetism is still there. So, okay. So, by nature all of us are lazy, okay. So, you can compare diamagnetism to laziness. Diamagnetism is laziness. So, we by nature we are all lazy, we do not want to study, we do not want to do hard work, right. But before exam we suddenly become ferromagnetism, a ferromagnetic material, and we start studying, right. And there are some students even during the exam they do not study, they remain diamagnetic, right. And some substances they are paramagnetic, they study but they just study sufficiently, they do not study more, they do not study less, they are paramagnetic materials, okay. So, in your classroom you can imagine all the students who are diamagnetic, who are paramagnetic, who are ferromagnetic, right. Now, let us see the question number 27. Magnetization of a sample is magnetic moment per unit length, magnetic moment per unit area, magnetic moment per unit volume, magnetic moment per unit current. Yes, 26A is the correct answer, Lakshmi Saudamini. Now 27. C, yes, magnetic moment per unit volume is the correct answer, not 27D. Maybe if you are incorrect, yes, Varija correct, Pradeep correct, Shaukat Ali correct, Lakshmi correct, Saudamini correct, you all are correct, Anisha correct, Sinchana correct, all of you are correct, it is 27C, okay, magnetic moment per unit volume. Now question number 28. The net magnetic flux through any closed surface is 0, is accordance with. Another easy question, I will just wait 10 seconds. Yes, Gauss's law of magnetism, 28A. Yes, 28A. Sinchana, Aman, Anisha, Pradeep, Shaukat Ali, Varija, all of you are correct. Anisha, you have mentioned the question number incorrect. Yes, I saw that. Yes. So, 28A. Now, second last question. In a permanent magnet at room temperature, so very careful, in a permanent magnet at room temperature, domains are partially aligned, domains are all perfectly aligned, magnetic moment of each molecule is 0, the individual molecules have non-zero magnetic moment which are all perfectly aligned. (29A) 29A, yes. Domains are partially aligned at room temperature, that means there is some temperature is high, that means the electrons are still vibrating, that means all the domains are not perfectly aligned. You can perfectly align them in a room temperature as well, but you have to put extra energy. They have not mentioned anything else other than permanent magnet. Even a weak permanent magnet is still considered to be a permanent magnet, okay, because their domains are not perfectly aligned. It is a weak permanent magnet. If you are considering an electromagnet on the other hand, and you are using say a material like iron, then definitely at room temperature also, if the current is sufficiently high, all the domains will be aligned, but they have not mentioned any special case. So, domains are always partially aligned, okay. The domains are partially aligned in this case. So, there are some cases, for example, neodymium magnet. I think the question number 30 is same. We have already answered this question. Question number 30 and question number 16 or 15 was same, okay. So, again those who are new, they can again try, they have missed the questions. So, I will give you some time. Varija and Pradeep, they have already seen the answer. So, I do not accept their answers. So, whatever Varija and Pradeep they are answering, they are wrong, okay. 30, question number 30, rest of the class, for rest of the class, okay. Shaukat Ali is saying 30C, Sinchana is saying 30C, Lakshmi and Anisha. So, needles N1, N2 and N3 are made up of ferromagnetic. So, N1 is ferromagnetic, N2 is paramagnetic and N3 is diamagnetic. So, if you bring a magnet, then N1 will be strongly attracted towards that, right, it will be strongly attracted towards the magnet. This is a paramagnetic, say they will be also attracted but weakly, whereas N3, it is a diamagnet, it will be repelled, okay. So, if there is a magnet, you keep it here, then ferromagnetic will be strongly attracted, paramagnetic will be weakly attracted and diamagnetic will be repelled. So, option C is the correct answer. And obviously, for all the students, something big is coming Monday 11 AM in the morning, because we have our Chakravyuh session on Monday as well at 6 PM. So, definitely we cannot do 2 live sessions parallelly. So, that is why we have scheduled 11 AM sharp in the morning. Be with us. We will be doing something great for all those who are preparing for KSET 2025 exams. Now, I know many of the students who were actually initially thought of, I will clear JEE, I am the smartest students, and after appearing for JEE mains exam, their confidence is somehow shattered. They now realized, okay, maybe JEE is not for us. Maybe we will prepare more better for KCET. If we prepare for KCET, it will be better for us. And some students still thinks that if we prepare for JEE, KCET will be prepared. Not 100% true, not 100% accurate. Okay, KCET question paper is a lot easier. So if you are preparing for JEE, your mind will be still complex mode that, okay, question paper, something trick is there, some trick is there, but maybe there is no trick. Okay, so that is why you have to practice KCET as well. And for all the KCET 2025 aspirants, something big will be, we will launch something new on 11 AM 3rd February. We have not yet decided the name of the series, that was yet under the discussion, but whatever we are going to do will be revealed on Monday, right? Till then, bye. And if you have any questions, don't forget to sir, please, next chapter I think electromagnetic induction. Monday will be electromagnetic induction, and then in between week, Saturday and Sunday, Friday is not my class, next Friday. So Monday I will be taking electromagnetic induction, then Saturday or Sunday there will be one lecture for electromagnetic waves, which will be recorded. Okay, that will be recorded, not super important chapter, so that's why I will give you a recorded lecture. And maybe just a few weeks before your exam, I will give you atoms and molecules, so that all the chapters will be completed. Atoms and molecules and EM wave will be recorded, all the other chapters will be live. Okay, so if you have any other doubts, sir, maybe one shot KCET series. Pradeep, smart boy. I will not tell anything about this. Thanks, sir. Bye, sir. Yes, bye, Anisha. I'll be back Monday 11 AM again, Monday 6 PM as usual. I'll be live. Till then, bye. And I want to close this session as well. Today is Saturday, so everyone, study hard, don't waste your time. Tomorrow Sunday we have some classes, but no live classes, so use that time, prepare hard, and whatever doubts, whatever concerns you have, you can mention that in the comment below. So I am closing this. Hope